Hello everyone, welcome to my channel Chem Insider. In the previous videos of reagents, we discussed about Gilman's reagent and also about the Grignard reagent. So now we are going to learn about the properties and the reactions of dicyclohexyl carbodiimide. So you don't exactly know what the full form of this complete reaction or the reactant is. In general, we call it with a short form named DCC. So the DCC, which we use for dehydration of certain reactions, that is nothing but dicyclohexyl carbodiimide. Okay, so this reaction has only two properties. One, it always carries out a dehydrating reaction. That is because of the presence of carbon-carbon double bond in these reactions. This carbon-carbon double bond reaction is quite similar to the structure of urea, NH2 C double bond O NH2, right? So therefore what we observe is this complete compound is more attracted towards the water molecule. As it always removes water molecule from the compound, it usually forms this NH2CONH2 type of a compound, but instead of one of the hydrogen will be having a cyclohexyl ring attached to the nitrogen groups. And further, because it is a dehydrating agent, it is always stored in anhydrous condition, because if it is stored in hydrous condition, it will absorb a molecule of water to form compound like this. Okay, so now how it is prepared, how is DCC prepared? DCC is prepared by carrying out dehydrogenation reaction on this given particular substrate. This can also be written as C6H5NH twice C double bond O. Okay, it can also be written as C6H5NH twice C double bond O. So this is how you can write down this reaction substrate also. When you treat this compound with magnesium oxide in the presence of aryl thionyl chloride, that is, when you treat this compound with MgO2 in the presence of aryl benzene ring or a toluene group attached with SO2Cl. So here for the removal of this ClOH group, we observe the removing of water by the MgO compound, not Mg2O, MgO compound. Okay, so this is how the reaction takes place, where we get the compound called dicyclohexyl carbodiimide, like this, N double bond C double bond N, and this is being attached to one more cyclohexane ring. Okay, so this is how we prepare dicyclohexyl carbodiimide reagent. Next is the important applications of DCC. So DCC, as I said, it is usually carrying out the dehydration reaction. But if you are considering for a compound containing a carboxylic acid and an amine group of two different compounds of carboxylic acid and amine, or a carboxylic acid with alcohol, or two alcohols, or two carboxylic acids, etc., there are certain different types of reaction which DCC might bring about. Like for example, if you consider for the reaction between an acid and alcohol, acid group and alcohol, this causes esterification. Okay, if you are treating acid with alcohol reaction, it brings about esterification process. Now if you use two alcohols, that is alcohol with alcohol, then it brings about etherification, that is nothing but formation of ethers. Ethers are formed when two alcohol groups are reacted with one another in the presence of DCC. Next, if you treat an acid with amide or acid with amine group, when you treat acid with amine group, it brings about a reaction of formation which is also known as a peptide bond formation. That is of the type C double bond O NH2. This type NH bond, that is also called as the peptide bond. And if you use acid and alcohol present in the same compound in such cases of a benzene ring, or if you consider for a cyclohexane ring, then it leads to the formation of lactone ring formation. Okay, lactone ring formation, or it is also leading to the formation of amide formation also. Next is the very important is Moffat oxidation and alpha beta unsaturation oxidation compounds. That is, when you treat DCC, with one more reagent called DMSO, this reaction is known as Moffat's oxidation. Okay, it is called as Moffat's oxidation. So in this process we observe two type of reaction. One is alpha beta hydroxy groups being alpha beta unsaturated carbonyl compounds being converted to beta hydroxy carbonyl groups. Alpha beta carbonyl unsaturated compounds is being converted to beta hydroxy carbonyl groups. Okay, this is one type of a reaction, and the other one being oxidation of alcohol. Okay, oxidation of alcohol. So this is again a one more type of reaction carried out because of the treating with DCC with DMSO. So this is a different reaction. This Moffat oxidation relates to oxidation of alcohol. Next, the last important type of reaction of DCC is it leads to the formation of peroxides or paracids. It also leads to the formation of peroxides and paracids. We'll discuss more about each of these different type of reaction with examples related to one another. Okay, so in this class we'll discuss about the reactions and how the mechanism of this particular dehydrogenation process takes place. So now, if you consider for a reaction of RCOOH reacting with alcohol group, if you are treating an acid with alcohol in the presence of DCC and pyridine. So why do we use pyridine is because pyridine is a base. It initiates the reaction by removing a proton from acidic carboxylic acid group. Okay, so the reaction mechanism is RC double bond O OH. So this has the acidic proton. When pyridine is treated with this, the pyridine knocks off the hydrogen or proton present in the carboxylic acid, leading to the formation of carboxylate anion. C double bond O, O minus. Now, this O minus attacks the carbon present in the DCC. So when you treat this with carbon double bond N, I'm just writing C6H11 because that is nothing but the cyclohexane ring. Okay, C6H11. This oxygen negative charge attacks the carbon. As a result, there will be shift in the double bond on the one of the nitrogen. Now, since there is a availability of a proton present from this particular first step, since there is availability of proton present, I'm going to write the proton over here itself. Now, once it is being knocked off, the nitrogen carries a negative charge, leading to the attraction of proton on it. So therefore, the compound will be R C double bond O O C NH C6H11 double bond N C6H11. Okay, so now an alcohol group attacks the carbonyl carbon of this carboxylic acid group. So R prime OH. So this lone pair of electrons present on the oxygen attacks this carbonyl carbon. As a result, we observe a shift in double bond of carbon and oxygen, which later relates to the reformation of double bond. As a result, because of the beta leaving group, this double bond being removed. So once the double bond is being removed to form a carbon oxygen double bond, there will be shift in the nitrogen structure. So the reaction will be giving the product R C double bond O OH R prime with a positive charge on oxygen. Okay, and the remaining is C double bond O NHC6H11 N minus charge with C6H11. Because oxygen can't carry 3 bonds, it loses some proton, which proton will be accumulated by the nitride ion, N minus ion. So leading to the formation of R C double bond O OR prime along with our compound C6H11 NH twice C double bond O. Okay, so this is how the reaction mechanism takes place. So what we can observe over here is, first the pyridine base attacks the proton present on the carboxylic acid. The proton of the carboxylic acid will be removed because of the base pyridine, which leads to the formation of carboxylate ion. This carboxylate anion attacks the carbon present in the DCC, which leads to the formation of negative charge on nitrogen, which is attracted by the which is later satisfied by the proton present in the reaction. Now, our alcohol group's oxygen containing a lone pair of electron attacks the carbonyl carbon, leading to a substitution of this reaction to form RCOOH R prime. Because oxygen is carrying a positive charge, that is because of the presence of 3 bonds. So therefore it has to lose a bond. So out of all the other groups, hydrogen is the better group. So therefore it leaves this reaction structure, leading to the formation of ester. So this is almost the same mechanism throughout the other reactions also. It may be etherification reaction or lactone formation or peptide bond formation, etc. The mechanism is quite similar, that is leads into the formation of C6H11NH twice CO compound. Okay, so this is about the important mechanism of DCC, how DCC works. So now here we have two alcohol groups. One is an aryl alcohol, that is nothing but the phenyl group, and the one is a methanol group. So here water molecule is being removed because of the presence of pyridine. It attacks one of the hydrogen present. So out of these two, this hydrogen is more acidic. So therefore pyridine attacks the acidic hydrogen from the phenol group. So once that hydrogen is being removed, it forms ARO minus structure, which later attacks the DCC, which later results in the relation of MeOH bonding to ARO. So therefore the compound formed will be so this is our compound form, that is our C6H5OMe. So you will have one more name for this compound. Can you name what the name of this compound is? So if you can, please comment down below what is the name of this product formed in the first example. Here we have two particular reaction of carboxylic acid when it is treated with DCC in the presence of pyridine, and treating a carboxylic acid with DCC in presence of H2O2. So this is a classic example for multiple substrate reagents leading to different products. Now, if you consider for the first reaction, as I said, if you are considering for two acid groups, it leads to the formation of what I said is a cyclohexane member ring. Now, if you observe carefully, this compound will give us a normal structure of an ester, or we can also say it as an anhydride. Okay, when you treat two acid groups, it leads to the formation of anhydride. Like first we get RCOO minus of one compound, which later attacks the DCC, which leads to the formation of RC double bond O, O of carbon, NH, C6H11, and double bond N, C6H11, right? So this is what the intermediate of this particular first process. Now, because of the presence of one more carboxylic acid, RCOOH, so the lone pair of electrons on the OH group of the carboxylic acid attacks the carbonyl carbon. Once this elimination or substitution process takes place, we obtain R C double bond O, O C double bond O R. So this is how we can prepare anhydride if you treat two acid groups with DCC and pyridine. Okay, so this is a simple reaction, direct straightforward reaction for the formation of anhydride by removing a molecule of water. But if you use DCC with H2O2, if you use H2O2 with DCC, in treating them with acid groups, what happens is the H2O2 compound donates a molecule or an atom of oxygen. H2O2 donates an atom of oxygen for this ROOH group. So we get a per acid, that is RC double bond O, OOH. That is first will be reacting acid with H2O2, which donates an atom of oxygen by losing a molecule of water. Okay, So now this reaction starts with DCC. When you treat this molecule, we'll have one more molecule of RCOOH, right? So we have one more molecule of RCOOH that will be attacking our carbonyl carbon, which leads to the cyclization, removal of OH group from this reaction. Therefore, we obtain RC double bond O, 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 C double bond O, R. So this is called as peroxide, but it is alkyl peroxide. The reaction product which is formed here is alkyl peroxide. Okay. This is how the reaction takes place. If you treat acid compounds with DCC and pyridine, we obtain anhydride. If you treat the same acid with DCC in presence of H2O2, we will obtain alkyl peroxide. Okay, so this is about for today. In the next video, we'll discuss some more examples which might conclude the completion of DCC reagent. Okay, I hope you have understood these concepts of simple examples and the mechanism involved in DCC reaction. If you have any doubts, please do comment down below, and don't forget to write on the name of the structure which we have prepared in the first example. Okay, I'll answer this question in the next video. If you don't know the answer, it is a quite simple one. Thank you for watching.